some x. So the area, this part we use it to ax, yeah? ax is the area under the curve y equal to x, y equal to ex. And above over the closed interval minus 1 to x. So here ax denotes the area. The area. So from here we have what? The a prime equal to what? A prime equal to f. Yes. So this function f is what? F is ex. Yeah. So here means a prime equal to ex. Yeah. A prime equal to ex. So a is equal to what? So from here we have which function, the derivative of a function equal to ex? Ex, yeah? So actually, just this function, ex should do plus a constant, yeah? So a plus c, yeah? C is a constant. So here x equal to ex plus c, yeah? This is the first step, okay? The first step you need to find c, okay? The second step is what? You need to determine c. Determine c. Now we can see when the right endpoint equal to the left endpoint, when x is equal to minus 1. So we have what? A minus 1 equal to what? A minus 1 actually is the area of this part, yeah? So a minus 1 is what? When x, you can see, this is the area. When x gets closer to minus 1, so the area actually is what? 0, yeah? So here is minus 1. Here is x. When x gets closer to minus 1, so we can see the area actually is getting closer to 0, yeah? So when x equal to minus 1, the area is what? It's 0, yeah? So a minus 1 equal to what? Equal to 0, yeah? A minus 1 equal to 0, we can see a minus 1 equal to what? Equal to e minus 1 power plus c, yeah? So from here we can see c equal to what? C equal to minus e minus 1, yeah? So here ax equal to what? Ax equal to ex minus e minus 1 power, yeah? So now the area in this interval is what? A1, we just fix the x equal to 1. So we can see the area. So the area actually is A1 is E1 minus E minus 1. So actually it's E minus 1 power. So this is the result. Okay? So here first, okay, the first step is we fix the left endpoint minus 1, yeah, and changeable right point x. So now we use ax. We use ax to denote the area under the curve over the interval minus 1 to x. So ax denotes the area, yeah. So from here we can see what? You can see the ax is the left endpoint, a is fixed. The right here x is changeable, okay? So here a equal to minus 1, x is here. So we have what? We have for this function a prime equal to f, yeah? So here a prime equal to f. Here for this function f is what? Ex, yeah? So we have a prime equal to ex. A prime equal to ex. So a equal to what? A equal to ex plus c, yeah? Because we know ex plus c prime equal to ex, yeah? So here, so x equal to ex plus c, yeah? So for this function we can see when x gets closer to a, actually x equal to 0, get closer to 0, yeah? When x when x get closer to a, actually x is get closer to 0, yeah? So a actually is 0, yeah? So here means that a minus 1 equal to 0. A minus 1 equal to what? A minus 1 equal to e to the power minus 1 plus c, yeah? So here this part equal to 0, so we can determine c. C equal to minus e minus 1. Minus e minus 1 power. So here we have the formula of ax. Ax actually is ex minus e minus 1 power. So now we need to find the area of this interval. So we just need that x equal to 1. That x equal to 1. So a1 is what? A1 is e to the power e minus 1 power. Okay. So this is the result. So this is the first 6.1. Okay. Now we go to the second 6.2. Now we see 217. I know it's a little fast. Okay. It's a little fast, but I have not have any other method because we have so many. Okay. We have so many to finish it, but we do not have enough time. So I will be a little fast. Okay. So if you have any question or if you have any you can not understand, you can answer and ask me. Okay. So now we go to the second part. The second part is 6.2. Okay, 6.2. Actually is what? Is the indefinite integral, okay? The indefinite integral. So now from 6.1 we know that a prime equal to fx. Okay. So here, for this, if I give you a function, okay. If I give you a function, give x. If I give you x, it's easy to find the a prime. Yeah. Now, I give you a function. It's easy to find the derivative. Yeah. But if I give the derivative to find the function, so this is the second, okay? The second, if I for this function, if I give a prime, now I need you to find x. So here the first part here is the derivative. So this part is the derivative, okay? So the second part, if I give the derivative, I need to find the function. So this here is what? Here is the indefinite or means the any derivative, okay? Any derivative or the indefinite integral, okay? So now here means I give you a function, it's easy to find the derivative. But if I give you the derivative, I need to find the function. So this process means I give in mathematics this process, okay? This process means the any derivative or the indefinite integral, okay? So now here, so we have the definition. We have the definition of function f a function f is called antiderivative of a function f. Here's capital F, okay? The capital F on a given open interval. Open interval if f prime equal to f, okay, for all x. For all x in the interval, okay? In the interval. So here, I give you a function capital F, okay? Capital F is called an antiderivative of a function f. On a given open interval, if f prime equal to f for all x in the interval, okay? So here means that if I give you a prime, okay? So here f is called an antiderivative of a function f. So here means the capital F, okay? Capital F is called an antiderivative of a function f. If the capital F, the derivative of the capital F equal to f, okay? So this is the antiderivative, okay? The definition. So here is easy. So here, for example, we can see 1 by 3, okay? 1 by 3 x cubed equal to what? Equal to x squared, yeah? So here we can see what? So here we can see 1 by 3 x cubed is what? Is an antiderivative of x squared, yeah? Because now we can see 1 by 3 x cubed derivative equal to x squared. So from this equation tell us that 1 by 3 x cubed is an antiderivative of x squared, yeah? So now actually we have what? 1 by 3 x cubed plus 1 derivative is also x squared, yeah? So here means what? Here means 1 by 3 x cubed plus 1 is also antiderivative of x squared, yeah? Yeah. So 1 by x squared, or 1 by 3 x cubed plus 1 derivative is also x squared. So this tells us what? 1 by 3 x cubed plus 1 is also an antiderivative of x squared. Okay? So actually here means what? An antiderivative of a function is not unical. Okay? It's not unical. We have many, okay? We have many. Actually here you can plus 1, you can plus 2, you can plus 3, yeah? So here now we have a question. If a function, for example this function, okay? For example, the capital F derivative equal to fx, yeah? So here fx, capital F is an antiderivative of f. If gx prime is also equal to fx, if g prime is also fx, so this tells us what? Tells us gx is an antiderivative of f, yeah? So now we have a question, what's the relationship between capital F and capital G? So now what's the relationship between between capital F and the capital G.
Yeah.
So what's the relationship between capital F and capital G?
Those would be equal or not?
They are equal. F and G equal.
Equal or
No, not equal. You can see here.
But F
would be equal or not?
No, not
That F of Fx equal to F capital Fx prime equal to Fx and capital G prime equal to Fx.
So here, yeah. Now from here you can see these two F and G, they are not the same. Yeah. For example, you can see this function derivative equal to x squared. This function derivative is also equal to x squared. But these two functions not equal. Yeah. You can see this function can be expressed by this function plus a constant. Yeah. So this is the relationship. Okay. So here now actually, so what's the relationship between these two functions? Actually, the function is we can see fx minus gx. So the derivative equal to what? F minus g prime equal to what?
0.
You can see f prime minus g prime. Yeah. F prime equal to what? Equal to f. G prime equal to what? F. Yeah. So f minus f. Yeah. So equal to what? 0. Yeah. So here means the derivative of this function equal to 0. So this function is what? So here, now we use the constant difference system. So we have fx minus gx equal to what? Equal to c. Yeah. Equal to c. Yeah. So equal to c. So here means what? Here means fx equal to what? Equal to gx plus c. Yeah. So here means what? Here means what? Here means if I give you a function, any derivative of the function is not equal. We have many any derivative, okay? Any derivative. But the relationship between the any derivative is the one any derivative equal to another derivative and another any derivative plus a constant, okay? Plus a constant. So here this is the result. Now we can see the page 271. 271, the system 6.2.2, okay? 6.2.2, if capital F is any derivative of F on interval I, therefore any constant C, the function fx, capital F plus C is also any derivative of that interval. Moreover, each any derivative of F on the interval I can be expressed in the form fx plus c by choose the constant c approximately. Okay? So here tell us that I give you a function, the any derivative have many, okay? Not equal. But the difference of any derivative is a constant, okay? Means one any derivative equal to another any derivative plus a constant, okay? So now I think that we should have a break 10 minutes. Okay? So any derivative, okay? So any derivative. So here means any derivative gives that if a function capital F is any derivative of function f our given open interval if f prime the derivative of capital F equal to f for all x in that interval, okay? And we say that if I give you the any derivative is not unical, okay? We have many any derivatives, but any derivative, okay? One any derivative can be expressed by another any derivative plus a constant, okay? Plus a constant. So here means what? Here means d dx So here all here now we can see f prime equal to capital F. The derivative of f capital F equal to f. We can write it in d dx. D capital F dx equal to fx. Okay. So here now we can use here we have another expression. Okay, another expression. So here means we have another expression means that the fx integral. Okay, integral fx equal to what? Equal to capital Fx plus a constant c. Okay, these two. Okay, these two expressions they are the same. Okay, they are equivalent. They are equivalent. Okay, they are equivalent. So here this side. Okay, this side like this. Okay, this side like this. Here means what? This side we have a name. We have a name means the integral sign. Okay, integral sign. And this f in mathematics. Okay, this f we have a name means the integrand. Okay, the integrand. Okay, the integrand. So here this constant c. This constant means that the constant of integration. Okay, the constant of integration. So here this means that the derivative of capital F equal to f. So this formula, okay, this formula tells us that the derivative of capital F equal to f, and this formula tells us what? Tells us that the any derivative of f equal to capital F plus c. Okay. So the any derivative, okay, the any derivative here, okay, here fx, here this means we have two names. Okay, the first name is the antiderivative. Okay, the antiderivative or what? This is the first name. Okay, the second name is the infinite integral. Okay. So we have two names. Okay, two names for this formula. Okay. The first is the antiderivative of f. The antiderivative of f. The second name is the indefinite. Okay, I'm sorry. Here is indefinite integral of f. Okay, of fx. So here they are the same. Okay, they are the same. The first is in the view of the derivative. Okay, in the view of the derivative. The second is in the view of the integral. Okay, integral or antiderivative. Okay, so antiderivative. Okay. So here the first tells us that the derivative of capital F equal to x. The second tells us that the antiderivative of f equal to capital F plus c, or the indefinite of f equal to capital F plus c. Okay. So here this sign is the integral sign, and this f means that the integral. Okay, integral. So here now we can see if we plus now. So here now we can see if we replace this f. If we replace this f. If we play from here we can see what? From here we can see fx equal to what? Fx equal to the integral of fx minus c. Yeah. So if we replace f by these formulas to here, so we can see what? We can see d dx, the antiderivative of f minus c equal to what? Equal to fx. Okay? If we replace this f by this formula, so we can see d dx, the antiderivative of f minus c equal to fx. So now we can see this derivative actually equal to what? Equal to d dx, the antiderivative of fx dx, yeah, minus d dx c, yeah, equal to fx. d dx c, this is 0, yeah? So here means what? Here means that we have this formula, okay? We have this formula. d dx, the derivative of antiderivative of f equal to f, okay? Equal to f. So now, so here this is we have studied, yeah. So this is new, okay. This is new, but they are the same, okay. They are the same. They are equivalent, okay. They are equivalent. They are the same. So here now I give some formula, and you must remember it, okay. Remember it. So take those, okay. Take those now. So the left side is the derivative formula. The right side is the equivalent integration formula, okay? So the first here is we know d dx x cube equal to what? Equal to 3x squared, yeah? The derivative of x cube equal to 3x squared, yeah? So here, so the equivalent integration formula is what? Is the antiderivative of 3x squared dx equal to what? Here, equal to what? Equal to x cubed plus c, yeah? X cubed plus c, yeah? So here, the derivative of x cubed equal to 3x squared. So this is the derivative formula, yeah? So the equivalent integration formula is what? Is the antiderivative or the indefinite integral of 3x squared equal to x cubed plus c, yeah? So this is the first formula, okay? So the second here, so d dx, the square root of x equal to what? Equal to, actually here is x to the power 1/2, yeah? 1/2, so here is 1/2 x minus 1/2 power, yeah? 1/2 x minus 1/2 power actually is what? Is 2 the square root of x, or 1 by 2 square root of x. Yeah? So here, so the equivalent integration formula is what? Is 1 by 2 the square root of x dx equal to what? Equal to the square root of x plus c. Yeah? So here means what? Here means the derivative of this function equal to here, yeah?
Yes.
So can you understand? So the derivative, okay, so here, so this formula tells us that the derivative of the right hand side, equal to what? Equal to the integral, yeah? The derivative of the right hand side equal to the integral, yeah? So this is the second, okay? Now the third, now we can see the d dt tangent t, okay? So the derivative of tangent t is what? It's second t squared, yeah? The second t squared. So here we have the integrand of second t squared dt equal to what? Equal to tangent t plus c, okay? So take the notes, okay? Take the notes. Take the notes. And now, we can see the d du u to the power 3 by 2, okay? U to the power 3 by 2 equal to what? Equal to 3 by 2 times u 1/2 power. Here 1/2 power. So this means what? So this means 3 by 2 u to the 1/2 power du equal to what? Equal to u 3 by 2 power plus c. Yeah, plus c. And now d dx x equal to what? Equal to 1. Yeah, equal to 1. So this there are set the antiderivative 1 equal to what? Equal to x plus c. Yeah? X plus c. And now for this one, d dx and x to the power r plus 1 divided by r plus 1, okay? So here equal to what? Equal to x to the r's power. Here r not equal to minus 1, okay? So the derivative of x to the power r plus 1 divided by r plus 1 equal to x to the r's power. To the r's power. So the equivalent integration formula is what? Is x to the r's power dx equal to what? Equal to x to the r plus 1 power r plus 1 plus c. Okay? So this formula, okay? This formula you need to, of course, you need to remember it. Okay? So how to remember it? Okay? How to remember it? Actually, here you can remember it to integrate a power of x. A power of x. So the power is other than minus 1. Okay? Other than minus 1 is add 1. Okay, add 1 to the exponent. And divided by the new pollen. Okay, by the new exponent. So here, integrate a power of x. So the power r cannot equal to minus 1, okay? The power r cannot equal to minus 1. Here r not equal to minus 1, okay? So add 1, okay? Add 1 to the exponent, okay? Add 1 to the exponent. And divided by the new exponent, okay? Divided by the new exponent. So here, so this one. And now we can see that d dx, d ln absolute value of x. This equal to what? Equal to 1 by x. Yeah? Equal to 1 by x. Or we can relate it x to the minus 1 power. So from here we have what? X to the minus 1 power dx equal to what? Equal to ln absolute value of x plus c. Okay? Plus c. And now d dx sin x, okay? Sin x, the derivative of sin x equal to what? Equal to cosine x. So the equivalent integration formula is the derivative or the antiderivative of cosine x equal to what? Equal to sin x plus c, yeah? Sin x plus c, yeah? And now we know that the d dx minus cosine x, okay, equal to what? We know that cosine x derivative equal to minus sin, yes? So minus cosine derivative equal to minus sin. So here is sin x, yeah? So here means that sin x, the antiderivative of sin x equal to what? Equal to minus cosine x plus c, yeah? Plus c. So take those, okay? So as here, this part. Now we can see here the d dx tangent x, okay? The derivative of tangent x equal to secant x squared. So here we have the secant x squared, the antiderivative of secant x squared equal to tangent x plus c, yeah, plus c. And now we have the d dx cotangent x minus cotangent x, okay? Minus cotangent x equal to cosecant x squared, okay? Cosecant x squared. So here we have the antiderivative of cosecant x squared equal to minus cotangent x plus c, okay, plus c. And now we know that d dx, the derivative of secant x, equal to secant x times tangent x. Secant x times tangent x. So from here we have the antiderivative of secant x times tangent x dx equal to what? Equal to secant x plus c, okay? Plus c. And now we know that d dx cosecant x, okay? Cosecant x equal to what? Cosecant x equal to minus cosecant x times cotangent x, yeah? So if we find the derivative of minus cosecant x, so equal to plus cosecant x times cotangent x, okay? So from here we have what? We have cosecant x times cotangent x dx equal to what? Equal to minus cosecant x plus c, okay? Plus c. So now, so this is this part, okay? Now, and we know that, for example, for this function d dx c times the function fx, okay? Here is the constant, c. Here is the constant. We know that we find the derivative. The constant can move through the derivative, yeah? So here equal to what? Equal to c times d dx fx, yeah? Fx. So here tell us what? Here tell us that c times fx, the antiderivative of c fx equal to what? Equal to c The antiderivative c times the antiderivative of f. The antiderivative of cf equal to c times the antiderivative of f. So here means what? A constant c can move through the integrand sign. Okay, integrand sign. So here a constant c can move through the integrand sign. Okay. And now I clear here. And now the last, so we know the derivative of fx plus gx. The derivative of fx plus gx equals what? Equal to d dx. The derivative of f plus the derivative of g. Yeah. So here is the sum of the derivative equal to the derivative of the sum. The derivative of the sum equal to the sum of the derivative. Okay. So from here we have what? We have the fx plus gx, the antiderivative of a sum equal to the sum of the antiderivative. Okay. So they are the same. Okay, they are the same. Of course, here d dx, if here is the fx minus gx, okay, if fx minus gx, the derivative of a difference equal to the difference of the derivative minus d dx, here is gx. Okay, here is gx. So from here we have what? The antiderivative of a difference equal to the difference of the antiderivative. Okay. Now actually here, for example, if we have three functions. Now, for example, for here, we have d dx, ce, fe, c1, f1x plus c2, f2x plus cn, fnx. Yeah? So the derivative of this function equal to what? Equal to c1 d dx f1, yeah, and plus c2 d dx f2, yeah, plus cn d dx fnx, yeah. So from here we have what? So from here we have the antiderivative of c1 f1x plus c2 f2x plus cn fnx, here dx equal to what? Equal to c1 antiderivative of f1 dx plus c2 f2, the antiderivative of f2 plus cn antiderivative of fnx dx. Okay? So this is the formula. Okay? So I think that you can take notes and remember it. Okay? And remember it. So So it's so many, yeah? But I think that it's easy because all of this you have remembered it when you started the developing.
Too
yeah?
easy, love say. But it's for you, not for us. It's really true.
So I think that I hope it's easy for you. For more.
It's too hard.
I think that it's not too hard just because.
No problem, Laushi. When you take exam, I just take my exercise book and copy.
Even Laushi is too fast. I like him.
Oh, I know it's it may be fast, but I have no other solution. I have no other solution.
So, Laushi, if I don't understand anything, so what is the benefit of your teaching?
I will slow down.
Yeah.
Because I will just
So you teach us because we.
So here, okay.
Laushi, you can take a decision because which chapter is very important. You can teach us the chapter and you can skip some chapter. It will be
The chapter 6 is very important. Okay. So I will slow down this part. Okay.
Yeah, right.
I will slow down this part. So chapter 6 is very important. So I will slow down. So chapter 6 is for the integration, for the indefinite integration and the definite integration. So first here, the definite integration is based on the indefinite integration. So here, this part, I think that all of you should do understand it. Okay.
please slow down.
So first you take notes and remember it. Okay, remember it.
We want to learn less, but we want to learn properly. Yeah?
So take the notes. Okay. So the remaining I will slow down. Okay. And I hope that all of you can understand. But if I slow down, I cannot guarantee that I can finish the book. Okay. If I cannot finish the book, so the remaining as you should do study yourself. Okay.
Yes, Laushi, because
Because exam needs to pass the examination.
exam we need to pass, we don't need to finish them. We have to learn and that will come.
Now, okay. Now for this formula, okay, the integral of x to the power r equal to x the power plus 1, okay, divided the new exponent and plus the constant. So here we use this formula to find. So the x square integral equal to what? The antiderivative of x square equal to what? So here x 2 plus 1 divided 2 plus 1 plus c, yeah? So equal to x cubed divided by 3 plus c, yeah? And now for the second here, x cubed dx equal to what?
X power 4.
X power 3 plus 1 divided by 3 plus 1 plus c, yeah? So equal to x to the fourth power divided by 4 plus c. Yeah? And now for here, for this one, x 1 by x to the 5 power equal to what? This one. 1 by x to the 5 power. So 1 by x to the 5 power, we can rewrite it by x. So 1 by x to the 5 power. Okay. So we can rewrite it by x to the what power? Negative 5 power. Yeah.
Yeah.
So equal to what?
X to the power negative.
X minus 5 plus 1 divided by negative 5 plus 1 plus c. Yeah? So equal to x to the minus 4 power divided by minus 4 plus c. Yeah? So we can rewrite it by minus 4 times x to the fourth power 1 by here plus c. Yeah? And now for here, for this one, the square root of x dx equal to what? The antiderivative of the square root of x equal to what?
1 over 2 root x.
Here is x 1/2 power, yeah? So equal to x 1/2 power plus 1 divided by 1/2 power plus 1, yeah? Plus c, yeah? So here is 3 by 2. Here is x 3 by 2 power plus c. So equal to 2 by 3 x 3 by 2 power plus c. Yeah. So actually it's easy. Yeah.
Yes.
So now, but I think that you should do remember if here is r equal to minus 1. R equal to minus 1. X minus 1 dx equal to what? So see the notes. So equal to what? 1. So here we can see here this formula r cannot equal to minus 1. So you cannot use this formula, okay? So here is what? So see the notes. Here is what? So we know that d dx ln absolute value of x equal to what? Equal to 1 by x. Yeah? Equal to x minus 1 power. Yeah? So here equal to what? Ln absolute value of x plus c. Yeah?
Yeah.
So now I think that so now you do access for here. Now, okay, so we have six antiderivative. So do it, okay? So do it. Use this formula, okay? Use this formula to finish these 6 antiderivative. The first is x to the 8 power So second is x, the power is 5 by 7. Here is x cubed times the square root of x. Here is the cube root of x squared. Here is 1 by x to the 6th power. Here is the power is minus 7 by 8. So 2 to the 6, okay? You can see plus the constant. So you the second is 5 by 7. Here is right. Here is power. Okay. So here the power is to right. Yeah. So plus. Yeah. The second is the power is 5 over 7. Okay. Yes. 5 over 7 plus 1. Yeah. So equal to what? Yeah. So here is what? 35 by 7. Plus 1 equal to x cubed. X cubed times x squared. So here x cubed. Here is 1 half power. Yeah. So we can do C plus 1 power. Times.
It's like
So here is x alpha power times x beta power equal to x alpha plus beta power. Okay. So here is not here is x cubed times the square root.
Here, x square, yeah. It's the cube root of x square, yeah. So here is what? So the cube root, okay. The cube root of x square actually is x square to the power 1 by 3, yeah. So it's x 2 times 1 by 3, yeah. So it's x.
Now let's see it, okay? I think it's easy, okay? It's easy. So now, here, for example, here, x to the power alpha times x to the power beta equal to what?
X alpha plus beta.
X to the power alpha plus beta, yeah? And x to the power alpha to the power beta equal to what? X to the power alpha to the power beta equal to what? Equal to x to the power alpha times beta power, yeah?
Yeah.
So here, the first one here equal to what? So here equal to x 8 plus 1 divided by 8 plus 1 plus c, yeah? So now, somebody forgot the plus c, okay? So here should be plus c, okay? So here is x to the 9th power divided by 9 plus c, yeah? So the second here is x to the power 5 by 7 plus 1 divided by 5 by 7 plus 1 plus c, yeah? 5 by 7 plus 1 is what? It's 12 by 7, yeah? So here is 7 by 12. 7 by 12 x to the 5 by 7 plus c, yeah? So for this one, okay? This one is x cubed times the square root x. So here is x cubed. The square root x actually is what? It's x to the power 1/2, yeah? So dx. So here equal to what? Here equal to x3 plus 1/2 dx, yeah? So here actually is x to the 7 by 2 dx, yeah? So this part is so actually equal to what? X 7 by 2 plus 1, here is 7 by 2 plus 1 plus c, yeah? So the result actually should be 2 by 7, 2 by 9, x 9 by 2 plus c, yeah? And here for this one, okay, here is the cube root of x squared. So the cube root actually is what? The cube root actually is 1 to the power 1 by 3, yeah? So here is to the power 8, to the power 2 to the power 1 by 3. So here actually is what? Here actually the power actually is what? The power actually is x 2 times 1 by 3, yeah? So, do you understand here? So here is what? Here is x 2 by 3 power dx. So equal to what? Equal to x 2 by 3 power plus 1. Here is 2 by 3 plus 1 plus c. So equal to what? Here is 5 by 3. Here is 5 by 3. Here is 3 by 5 plus c. Yeah? And now for this one, here 1 by x to the 6th power. So we can rewrite it by x to the power minus 6. Yeah? So here equal to what? So here equal to x minus 6 plus 1 divided by minus 6 plus 1 plus c. Yeah? So here equal to minus 5, 1 by 5 x minus 5 power plus c. Yeah? So you understand? You stand up. So what's the additive?
I come from the bathroom.
So you are.
Yeah, you can check the address. I come from the bathroom. I was there.
So you are the student of math class.
Of course.
Of course. So you of course stand up. yeah. Stand up.
I don't understand that.
You don't understand. So why you go out?
I was in the bathroom.
Toilet. So can you understand it here? So I want to know how you can pass the maths. So how can you pass the exam? You will pass. Okay. So here, now we can see here is x minus 7 by 8 plus 1. Yeah. Here is minus 7 by 8 plus 1 plus c. Yeah. So here minus 7 by 8 plus 1. Here is 1 by 8. Yeah. So here is x 1 by 8. Here is 1 by 8. 1 by 1 by 8. So here is 8 plus c. Yeah. So this is the result. Okay. So I think it's slow, yeah?
Yeah.
So can you understand better?
Yeah.
So class is over.